As a matter of fact, we got a gander at a couple of dazzling pictures as the James Webb Space Telescope, JWST, peers back around the beginning of everything that has uncovered a revelation that challenges the outer layer of our comprehension. This new revelation has instigated the interest of cosmologists and researchers and recommends a possibly gigantic occasion that could change the universe. Taking everything into account, the finding is influential for the point that it brings up issues over the justification behind our cosmic presence. Might this revelation at some point at last prompt the fruition of all we be aware? Is the universe near the genuine edge of a momentous occasion, past our ongoing understanding? Go along with us as we inspect the most recent openness of the James Webb Telescope and how it could shape the universe. At the point when we analyze the universe's edge, we start with the noticeable universe. It looks like seeing through a window into the district past the discernible universe. The recognizable universe incorporates all that could be as of now seen, estimated, and investigated with our telescopes and space missions. It is various stars, cosmic systems, and grand bodies that are conspicuous to us. Nonetheless, the obvious universe is fundamentally a piece of the entire universe, a little slice of a monstrous pie that people can survey and see. However, the general size and sort of the universe stay a secret. The width of the conspicuous universe is around 93 billion light-years. This figure is the deferred outcome of different parts, including the distance that light can go in one Earth year, 9.46 trillion kilometers or 5.88 trillion miles. A light year is the distance light voyages, the speediest thing in the world, in 1 year. The assessed age of the universe since the enormous detonation is 13.8 billion years. This suggests that light radiated by objects in space that we can see has been going toward Earth for almost 13.8 billion years. That proposes that the recognizable universe is 13.8 billion light-years toward each path from Earth, bringing about a width of 27.6 billion light-years. Notwithstanding, Hubble's regulation shows that space has been extending since the huge explosion, and subsequently, the recognizable universe has been advancing. Evaluations of this development show that protests that discharged light 13.8 a long time back from a distance of 13.8 billion light-years are presently fundamentally farther away from Earth, around 46 billion light-years away. This demonstrates that the recognizable universe reaches out more than 46 billion light-years toward each path from Earth and has a measurement of around 93 billion light-years. So when we say the recognizable universe's extensiveness is 93 billion light-years, we're looking at an impossible stretch around 13.8 quite a while back in an unprecedented effect. This effect started what we as of now allude to as the boundless extension. Since that crucial second, the universe hasn't just been growing, yet has likewise been speeding up. Complex peculiarities like dim energy appear to be driving this speed increment, extending the universe's limits further separated. Matter started to frame under the draw of gravity as the universe extended. This gravitational fascination pushed particles together, bringing about the advancement of designs like stars, universes, and at last planets like our own dear Earth. Given the universe's steady development, the recognizable universe develops by another light-year each Earth year. At the same time, light from farther items keeps on arriving at Earth. Curiously, this implies that we are seeing progressively a greater amount of the universe as time sneaks past. While we will constantly not be able to notice the entire universe from Earth, the field of perception is ceaselessly extending. Propels an innovation catch and break down electromagnetic radiation past the apparent range, permitting us to find and view distant individual cosmic systems, bunches, and superclusters in the discernible universe. Explicit telescopes, similar to radio telescopes, X-beam telescopes, bright telescopes, infrared telescopes, and others, have been important in such manner. The amazing Hubble Space Telescope and James Webb Space Telescope have empowered the perception of the main stars and worlds that emerged in the noticeable universe, making these miracles more open to people in general. Regardless of its immeasurability, the universe is unconventionally unfilled. Regardless of whether we decreased our whole nearby planet group to the size of a quarter, the closest star would in any case associate with 2 soccer fields away. This monstrous vacancy broadens just inside our own smoothway world, which is one of billions in the detectable universe, giving us a feeling of the gigantic scope. You might be asking why we can't simply see everything there of reference. There are different clarifications for this limit. Notwithstanding the way that light is the quickest object in the universe, it actually requires investment to go through space. This implies that when we take a gander at far-off objects, we are basically thinking back in time. The farther away an item is, the more its light has headed out to contact us. It resembles looking through an enormous time machine, unwinding the historical backdrop of our universe as we witness cosmic systems millions, on the off chance that not billions, of light years away. Notwithstanding, there is one more variable at play. The universe is extending. Consider the outer layer of an inflatable canvas in dabs. As the inflatable expands, the specks move separated from each other. As the inflatable grows, the universe follows a comparable guideline. Worlds float away as the texture of room extends. The light produced by far-off objects goes through a change known as redshift. Due to this development, light frequencies are extended as items move away, moving to longer frequencies, which are for the most part seen as a rosy variety. A few heavenly bodies at last cross a basic distance, known as the inestimable skyline, where their light is just excessively far away to contact us due to the universe's growing nature. Given these two focal variables, the light's process through time and the extension of the universe, it's not shocking that we haven't noticed the whole universe yet, even with the most exceptional telescopes and innovation. Our vision stays restricted by the essential attributes of the universe. We ought to dive a smidgen more into these ideas. The universe's size is amazing. Researchers use estimations like light years to show the distance that light goes in a year, generally 5.88 trillion miles or 9.46 trillion kilometers. Our universe, the smoothway, is around 100,000 light-years across. Indeed, even inside our cosmic system, the nearest star to our Sun, Proxima Centauri, is around 4.2 light-years away. At the point when we investigate space, we can see systems billions of light-years away, implying that the light we see from those worlds started its excursion billions of years prior, giving us a brief look into the universe's initial history. The secret of the universe's edge and the mission to comprehend its potential limits absolutely draw in the consideration of people from different fields. While conclusive responses keep on evading us, three huge hypotheses have arisen, each giving an unmistakable point of view on the immeasurability of room. The principal hypothesis sets that the universe is limitless, with no recognizable end. This thought lines up with the cosmological guideline, which expresses that the universe is isotropic. Its consistency and obvious appearance are something similar from each vantage point. Assuming this hypothesis is legitimate, it proposes that the universe has no restrictions and can grow endlessly toward each path. The subsequent hypothesis offers an elective view, contending that while the universe might be limited, it misses the mark on noticeable edge. All things being equal, it is contrasted with an immense bended space, similar to a globe. In this situation, if one somehow managed to go toward any path endlessly, they would ultimately get back to their beginning stage, similar as circumnavigating the Earth. The third hypothesis, the multiverse speculation, presents the fascinating idea that our universe is simply one among many. Envision a monstrous number of universes, each with its own arrangement of actual regulations, constants, and attributes. These universes may be totally particular and work freely of one another, or they could be interconnected through complex systems, shaping a huge and multifaceted multiverse. Investigating these hypotheses creates both logical and philosophical premium. The possibility of an endless universe challenges our ideas of room and our impression of its boundlessness. On the other hand, a limited universe without an edge difficulties our ideas of cutoff points and development, recommending the chance of rehashing designs inside the texture of room. The multiverse speculation, with its equal universes, offers a rich scene for investigation, proposing the presence of domains significantly not the same as our own. If valid, it would suggest that varieties in actual regulations and principal constants could prompt completely various types of presence, opening up a huge span of potential outcomes past our ongoing comprehension. In any case, these thoughts stay theoretical and subtle. Investigating the universe's edge includes huge difficulties. It is challenging to decisively demonstrate or invalidate these speculations because of the endlessness of enormous space and the impediments of our ongoing observational instruments and innovation. The disclosure of the universe's edge has been a spellbinding excursion wealthy in hypotheses and reflections. One vital instrument, the James Webb Space Telescope, JWST, stands apart as a reassuring sign, uncovering bits of knowledge into the secrets that cover the universe's starting points. This groundbreaking instrument can possibly uncover our universe's mysterious history, permitting us to acquire information a long ways past what was recently envisioned. The JWST is a specialized wonder, explicitly intended to notice the universe with unrivaled precision. Its extraordinary elements empower us to investigate the starting points of the universe. The JWST has tracked down gigantic worlds that date back between 500 million and 700 million years after the huge explosion. As per ongoing examination distributed in nature, these antiquated worlds challenge assumptions with sizes fundamentally bigger than expected for their age. These stunning disclosures cast uncertainty on laid-out speculations about the arrangement and advancement of worlds in the early universe. Cosmologists at first expected to notice little, youthful worlds during the telescope's perceptions. All things being equal, they were dumbfounded to find these enormous substances, which have reshaped the account of infinite advancement. The presence of these antiquated systems is especially astounding, going against winning idea. These cosmic Goliaths have arrived at an equivalent degree of improvement as our 13-billion-year-old smooth way. As indicated by Dr. Lear, the lead specialist of the review,